Good afternoon, Jan.
Good afternoon.
How do you do, sir?
Doing fine over here. The weather is nice outside. It's about 19 degrees Celsius in wintertime, so we don't have to complain.
Excellent. Yes. Yeah, I'm trying to do the arithmetic in my head. I still think in terms of Fahrenheit.
Fahrenheit is not my thing.
But yeah, it sounds fairly warm for this time of year.
Well, yesterday around this time I went out for a walk, just like this, without any coats.
Oh wow,
So
very
it was
nice.
it was nice and sunny.
Excellent. Yeah, I'm
But
testing out a new old camera. I have my uh, Logitech C922 back from my wife. I see that it was doing some autofocus there, so we might need to.
yeah, but it seems like less sharp than your normal camera.
Yeah, I think yeah, because it's got it's a shallower depth of field, so the background is
Mm.
a bit more blurry, and it should be focused on the foreground, which is supposed to be more pleasing. So I don't know. I've got the other
Uh,
one right next to it, so I can switch back and forth.
and this one is supposed to be a better one, or
Yes, yeah. Actually, during the pandemic, I got this one just before we went into lockdown. But yeah, during the pandemic, these things were really hard to come by because everyone was going on Zoom, and it's like I want a really good
Mm.
camera, and this is this is actually a really good camera.
And then your wife confiscated it.
Yes, yes, because during that time she was doing a lot of scrapbooking videos, so she was filming top down on her desk, and then also
Mm.
filming her face and mixing those two together, and so the focus on the other camera was just way off for what she was doing. So it's like, okay, you need this one. I'll take that one.
Yeah. But just now I don't know what you did, but just for a few seconds, your image got a little bit more color.
Oh, interesting.
Um,
Okay, must be
uh,
doing auto white balance.
and it was more pleasant image because the
Okay.
colors are rather fade. Um,
Hmm.
yeah.
Okay. Well, I'll play around with it
You-
a bit more, and I think I just went
yeah.
blurry again. I
Yeah. The
might
the,
actually
the,
just switch back
autofo-
to the other one.
the autofocus is well, perhaps it's just a matter of settings that you can.
Yeah, I know that I can turn that off, but yeah, with the other one, it's just got a locked on infinite
Mm.
focus, and yeah,
Yeah, I
that's
don't
what we're
know
used to.
my camera is. I it's always in focus, I think,
Hmm.
or always out of focus. No, it's just a Logitech. I don't know which type it was, but uh, well, I should see that in the settings. Um, Video. Where is that? It's an HD Pro webcam C9 920.
Okay, that is actually really yeah, yeah. This one's the 922, so it's
Mm.
really similar to the one I was just using. Okay, but I switched back to the other one,
Okay,
so
because
this is the
I
video
went
we're
to the
used to.
settings, so for a while I didn't see you, and I have the
Mm,
impression that the image is more colorful now and more focused.
okay, well then, this is what we'll keep for now.
Okay,
Excellent.
good. I sent you the comments on the chapter 6,
Mm-hmm.
um,
Yeah, I see. Thank you so
which was
much.
which
Yeah.
was very strange. It was very small portion of the text, but I got all the points. And before that and after that, everything was all right.
Interesting.
It was
Yeah.
nothing terrible, but at a certain moment you switch to a kind of hypothetical, like nothing exists yet.
Oh, okay. Right.
I say, yeah, but the runtime is available,
Uh-huh.
and the .NET version is available. So
Yeah. Yeah, that's true. Yeah, I should strengthen that language. Don't be quite so coy there, because I do at the end of that chapter say, "Hey, and there's Jinaga, and this is what it does." Um, yeah, yeah. I think what I was going for there was saying it's kind of the way that I think about all of my projects is that if a thing existed, what would it look like, and then what must it look like, and derive the features from the desired benefits, and then finally say, okay, now here's a thing that has those features. Um, so yeah, I think I was just trying to take the learner on the reader on the journey of let's imagine that something exists, and then we can do it. Okay, now I built one.
yeah, but
Yeah.
at least to me, but I'm not native English, but it gave me the impression it doesn't exist yet, which is completely not the case. On on one hand, in the beginning, I thought this chapter is very difficult for somebody who doesn't know more about Jinaga, who's just reading the book. Because in fact, you touch everything. You touch specifications. You spoke about it in earlier chapters, but here you really go quite more deep in it. Inverses, feeds, all the configurations of the replicator. So all these things come together, and I thought it's too complicated. But on the other hand, it gives a very nice overview of what is to come in the next chapters.
Yeah. Yeah, and yeah, there has to be some point at which it all comes together. Yeah, and it's kind of how we teach lots of subjects, but math in particular, um, versus how people learn. It's really weird that we seem to get this wrong all the time. But we always like, especially with programming. Yeah, I was just recently like last year teaching some high school kids programming, and you start with like, here are the basics. Here's how you can declare a variable. Here's how you can assign a value to it, and it's like that means absolutely nothing to them. They haven't used it, and then it's finally toward the end that we're saying, okay, now let's build a tic-tac-toe game. It's like, oh, okay, now I can understand why I'm doing all these things. Um, and so yeah, here I wanted to motivate the things that were to follow. So kind of like at the beginning, I motivated the need for consistency, and then here's how you achieve consistency. All the way up through CRDTs. It's like, okay, now we've got some mathematical foundations, but now here's how here are all the things that you need out of a distributed system, out of a network of computers that are going to exchange information, and kind of motivate that, show you how you're going to put the pieces together, and then, okay, now here's how we're going to actually build the pieces. If we were to save putting it all together till the end, then there's a lot of work you have to do without understanding why you're doing the work.
Yeah.
So I kind of like it in that order.
Perhaps I didn't mention it in my mail, but perhaps in the beginning of this chapter, just put a warning, like this is an overview. Don't be sad if you don't understand it immediately. Just go over it. We come back to the details in further chapters.
That's a good idea. Yeah.
Yeah.
Yeah, because I like touch on feeds, and then it's like, if you were to look at a specification, you could break feeds here. Oh wait, let's go to the next thing. It's like, wait a minute, are you sure that always works?
Because here you explain the feeds in just 1 or 2 pages.
Yeah.
But if people really want to understand it, like the example where you break it up in 4 feet, if this is the first time, people are not going to understand why. But so with a little warning in the beginning, don't try to understand this.
Yeah.
This is just an overview.
Yeah, and that explanation, as I'm as I'm fond of doing, that explanation is actually wrong. I like to be wrong before you be right. But the correct explanation takes an entire chapter. So it's
Yeah.
like, yeah, let's imagine that you could just take this graph and you can just and just pretend that these are the right places to do it. Okay. But that gets you the idea that you're taking a graph, you're splitting it up, and you've got multiple feeds in order to satisfy a particular specification. But yeah, a warning up front that would definitely be in order.
There is only one thing which is a little bit unlucky. So this is chapter 6. Then 7 and 8. 7 is about the patterns. 8 is about the state, I think.
Yes.
And these 2 chapters are not really an explanation of this, of 6. It's only in so 7, 8 from the 9th chapter onwards, which is was it security?
Yes.
Yeah. So there you touch on what we summarize in chapter 6.
Yeah.
So
Okay.
maybe bring this chapter after the one on the state.
I could see doing that. Yeah. My motivation was to get this as soon as you had enough context to use it. But
because if you postpone this, the motivation for the people, they will have to wait longer. But now in this chapter, you make them very curious. And then you come with 2 chapters, which...
Yeah.
Another possibility would be to put 7 and 8 completely at the end. I don't know whether that would
no,
be
I
a
think
problem.
I think they're pretty important for a lot of people, and the motivation for moving 12 and 13 to the end, which you haven't looked at yet, but those are the proofs of feeds and query inverses. In fact, I haven't shared 13 with you yet. I'm still writing it. But the idea is that the people who are willing to stick through it and actually follow along with 12 and 13, they've put a lot of work into it, and they're expecting to help build these systems, or at the very least understand how they work on the inside. The people who want to use the systems without fully understanding how they work, or without building them, they can drop off earlier. So the people who want to use an immutable runtime definitely need to know the patterns, and definitely need to definitely need to know, what was the other one again? This was before security.
Date.
Yeah, the workflow. Yeah. Yeah, those are immensely important. Yeah.
So
I think moving those up and putting immutable runtimes after may make a bit more sense. I'll see how that flows.
It's your book. You have to decide about that.
Yeah.
No. He's gonna be silent. So don't disturb me.
Nice. Yeah. Focus time. It's like it's historical modeling time.
Yeah. No, if I see the number, it's not a customer. It must be probably publicity.
Yeah.
That's one of these annoying things here in France. Even on the mobile phones, they disturb you just with publicity for whatever.
Yeah, to get out and vote or that kind of thing. Yeah.
There is no way to get rid of them. Yeah, it's illegal, but the government is not doing anything against them, I have the impression.
Okay, that kind of, yeah. Yeah, so true. Yeah, on iPhone there is a setting to block unknown callers. So if the caller is not in your contacts list, but with customers you don't know where they're going to be calling from, so can't really do that.
You can block a certain number, but next time they use a different number.
Oh yeah,
So
yeah, that doesn't work. Yeah, block unknown callers is whitelisting versus blacklisting. Whitelisting works, but it works too well. Yeah, if you've got customers who are going to be outside of their whitelist. But yeah, anyway, yeah, last time we went through some Jinaga.JS stuff, some Jinaga.net stuff, ran into all sorts of problems, and as it turns out, I've been able to fix all those issues, and then some, because my the team at Improving that is working on a Jinaga.net Maui application, they ran into something closely related, and so I was able to get that fix in as well. So lots of fixes around versioning. Still don't have the complete versioning story the way that I want it, but it's getting pretty close. So
I was happy to see that you treated the transformation as a third option for versioning in chapter 6.
Oh yes. Mm-hmm.
Yeah.
Yes.
And I'm still convinced that that will be the most useful option.
Yeah, it's definitely
I know
the
we don't
most
agree on
complex one.
that point.
Yeah, but already I'm seeing people using Jinaga in the real world and using it differently than I do. And so starting out with just the naming conventions. Yeah, I use lowercase because I'm used to JSON, and then when you see that in .NET, I carry over the lowercase so that it's compatible. But then also this team, they've decided to use history as the name for what I call prior when doing the mutable property pattern. And I said, well, that's not incorrect, and it still works just fine. But my convention is prior. The immediate prior. It's not the full history. So they might. I'll have to see how they end up using it. Are they actually putting the full history in that array? And then I can tell them, no, you don't need to. You can just do the most immediate versions in that array. But yeah, so little conventions that that I like. They've chosen some other ones. Which is telling me I probably need to get the Jinaga.net website up and running and document those conventions, and then at least as a community we can start to standardize on something.
Because that would be nice to have real good conventions that everybody uses the same system.
Mm-hmm. Yeah.
Even if it's perhaps not the best convention, at least there is a convention.
Yeah. Yeah, and the conventions are kind of as they're currently documented are kind of in two different places. Partially in the book, and then partially on Jinaga.com. So even for JavaScript, in fact, I should just have. Well, I'm going to have Jinaga.JS. So Jinaga.com is for JS, and Jinaga.net is for .NET. But yeah, they should have a shared conventions area, because I want people to be able to go to the one that they're using. But yeah, that shared conventions area will be. We're going to use these conventions because it's useful to collaborate between these two ecosystems. So yeah, that is on the backlog, and pretty high up on the backlog. We're getting past all the things that are blocking people from actually building applications, and okay, now you can actually build one. Still very important on the backlog is to make Blog Maui feature complete, so you can say this is a full working example, and I can see some useful patterns in here. But yeah, so I've got some fixes to demonstrate. Do you have anything else that you want to talk about before we do that? Okay,
No,
cool.
not for the moment.
All right. So let's do the share of the screen. And then there we are. Excellent. Okay. Okay, so the last time we saw the terrible chat app, we're trying to make it a little bit less terrible. So I'm going to do an npm well, let me do an npm CI, just make sure that I've got the right versions of everything installed right now. So this is using Jinaga 5.7, Jinaga React 4.1.1, and when we ran this, we had an issue with what was the script? npm run dev. Okay. We had an issue with having older and newer facts. Being able to bring something in from the replicator when we're changing the structure. So if I go to the Jinaga topic here, then it's not able to pull in anything, and that's because we ran into this. The fact does not have a field named timestamp, and that comes from doing the message list view model, where we project the timestamp right here. Yep. So while running the specification, it was specifically pulling timestamp out of all of the facts, and ran into one that didn't have one because it was serialized before I added the timestamp field, and threw an exception. So that's not what we wanted to do. What we wanted to do is instead have a default, so that we get back, in the case of JavaScript, since we don't have full type information, the default that we can give it is just undefined. It doesn't know what type it's supposed to be. So if we now npm update Jinaga and Jinaga React, then, well, let's see. Did I get the latest? It's still on 5.7.0. That's because this is a major version bump. So npm install Jinaga latest and Jinaga React latest. Okay. Now we are on 6.01, and Jinaga React is 5.01. Excellent. So start it back up again, and so it has refreshed. So now I go to the Jinaga topic, and I get a different error. So the thing that we ran into last week was this error was just this part here. Specify the type and fact of all predecessors. The type of the fact and all of its predecessors. That didn't really make sense in context. I thought that it was an internal defect bubbling up, but as it turns out, there's a defect in the code, and I just couldn't understand it from the exception. So I changed the exception. Never let a good error go to waste. And the problem that I found was that right here I was doing j.hash of a projection, not a fact. So this is the projection that has the ID, text, timestamp, and sender names. And I'm trying to hash that. So, so here, I improve the error message. You cannot hash the object. It is not a fact. And then it shows you precisely where it is that you're trying to do it. So, yep, trying to hash right here. Is it gonna show? Yeah. Even brings it up in the browser in here. So, well, yeah, it's showing Jinaga doing that, but yeah, further down here, this is your message view model. That line right there. Change that line. So, the correct thing is just, well, we've already done j.hash right here for the message fact. So this actually is message. This one here, well, that's the error message. This one here, let me find a good message to hover over. Yeah, this is the projection, ID, text, timestamps, and sender names. Then the other thing that I did, in addition to fixing the error message, is I made the compiler a bit more strict. So now j.hash requires that the parameter have a fact, a type property. So property type is missing in this thing, but required in type string. So you get some indication at runtime that you're making an error. You get some indication at compile time that you're making an error. But the fix is simply message.id. And then with that, it is able to pull in all of the stuff. So it got past that and it pulled the data in. So now these are the old facts that were giving it trouble. And right here, this triple question mark, that's coming from, well, I haven't actually done that yet. Sorry, that's the question mark there. Timestamp. This part right here is not showing up on these old messages, but it is showing up on this new one. This one should have a date. So I created that message after having created the adding the timestamp to the model. So that one is version 2. These are all version 1. But I'm using a technique that I love to talk about called structural versioning, where you don't actually have a version number on your data structures, but instead you use the shape of the data structure. And you say, okay, it's the one without the timestamp, it's the one with the timestamp. And then you just test. So in this case, if it's not there, you're just not showing it. And you are, in timestamp to string, sorting it to the top, because these are older. And you can't tell what order they should be in. So yeah, these are all in a weird order. Actually, these are in exactly the same order, the right order that's weird. It usually doesn't get the order right just by accident like that, but it did this time. Okay, so that was the fix on the Jinaga.JS side, is to just give better error messages in the compiler and in the runtime. That was it.
But then if you want to use this structural versioning, in this case, you're just checking the absence of the timestamp field.
Yes.
Or you would calculate the hash of the structure and use that as a version number.
Yeah, that is a really good point. The hash of the structure. So in JSON, so let's just look at this not as a Jinaga fact, but just really as a JSON object. So in JSON, if you were given an instance of message, you would just have some properties on it. And you would have to kind of interrogate what are the types of those particular instances. So if you first created the message and you said new message datetime.utc now, you've got a date as the timestamp. But then when you serialize it, JSON doesn't support actually serializing dates. It internally converts those into strings. So round trip, now you got a string, and it looks like a different type. But here in TypeScript, we've defined this one type to be date or string, and we really want to treat it as one type. So that causes problems. If you have an array of predecessors, like so far, we don't have the mutable property pattern in here, but but if we did have mutable property, then one of these predecessors would be an array. When you take a look at an instance and that array is empty, then you can't tell what type should be in the array. So,
We have another problem.
Yeah, without full type information, it would be difficult to infer the type of a JSON object. However, here we've got some type information. So in Jinaga.JS, we have to construct a model so that we know which type is supposed to be the predecessor of which other type. And it can kind of build that type graph. In Jinaga.net, we don't need to do that because we've got full type information coming from the compiler. And we just use reflection to get the same thing. But I could extend this language and say not just .predecessor, but I could also say .field. And you could fully describe the types that you've got here described in TypeScript in such a way that they would be preserved at runtime. So that is a possibility. It would add more burden to the developer. That they would have to fully describe the model. But there may be some benefit, so there may be some trade-off there.
Because then the versioning can be fully automatic. While now, if you test whether the timestamp field is absence or not, so for every version you will have to find something that is different, and that is representative for that version. So it's up to the developer to come up with a solution. While we want the runtime to be to make the decision automatically. Yeah,
and this is actually kind of similar to what I noticed in in the different workflow patterns, figuring out what state an entity is in. So usually we use all the history that has happened in order to figure out what the current state is, and now we're using the current state in order to figure out what to do next. So show me all of the orders that are in the state of pending, and now I know this is the queue that I need to work in order to do the next thing. To pick, pack, and ship the order. But if you actually look past state and look to, well, what is it that I'm trying to do, then you get a more useful query. So that's where we end up with, show me all the orders for which I have not picked the product. And then it's like, okay, there's that list. The next thing to do is pick. Once you pick it, it removes it from the list. So state was kind of an intermediate thing that we added because we like to think in terms of mutable properties. So I think this is something similar. I would say that version is something that we've added to the structure because we like to think in fixed shapes. But if you look past that and say, well, why do I need to know the version? Well, I need to know whether or not I can display a timestamp. And I need to know whether or not I can sort by timestamp. So, so if instead you accept undefined and then kind of roll that into the sorting, then excuse me, oh goodness, you get the behavior that you're looking for. And this, if there were many versions that didn't have a timestamp and many versions that do, you wouldn't have to know that full set of those versions that don't and those versions that do. You just, is there a timestamp or not? So that's really where I like to take structural versioning is, not so much that the structure is the version, but that you don't care about the version, you care about the structure. So, so there's that. Plus, there's the fact that in JavaScript, so we're looking at TypeScript. All this type information gets erased, and we just run it as JavaScript. And in JavaScript, we just get a JSON object that has a type string. And if that string is chat.message, then it's going to come back from the specification. It's going to come back from the query, and you deal with what you get. Yeah, this right here, behind the scenes, what it's doing is injecting a proxy into select and then seeing what you do with it. So when you say message.timestamp, it says, oh, okay, you are interested in the timestamp field. Let me record that, and that becomes part of the specification. And now when running the specification, it actually tries to extract the timestamp property at that point. And so that was being a bit too strict and throwing an exception. But here, just be loose and return undefined. In order for it to determine what version, if we wanted to use the hash of the structure as a version number, we would need to find a way to express all the different versions that it could be, which in TypeScript, I can't see a good way to do that. In .NET, I can see a good way to do that. We'll get to that in just a little bit. But you would have to express all the versions that it could be, and then pick the one that matches the most closely, and then treat the JSON object as if it were that particular class. So then let TypeScript take over from there and say, and you pat TypeScript on the head and you say, yes, this is really an instance of this type. Trust me on that. And yeah, I have a hard time in this type system figuring out how to do that and how to make that useful. Whereas this is a fairly simple thing to implement, and it's useful, and it's also kind of the way that JavaScript developers already think. If you've got JSON coming in from the outside world, and the replicator is the outside world to your application, to your client, you don't know if you've ever seen that version of the fact that's coming in. This might be an old version of the code, and you don't, and there's some new facts that new versions are sharing. You don't even have the type to express those. So yeah, you just take that JSON, and then you see, well, you tolerate the fact that things aren't going to be exactly as you expect them to be. And that's just the way you have to work in the JavaScript world.
Okay.
So all that describes kind of where I ended up here. Although, yeah, that does leave things up to the developer. And so one of the consequences is that the way that you use TypeScript, if you turn the strict mode on, topic and user cannot be null. But maybe the fact that you didn't have a topic predecessor, didn't have a user predecessor. String is not a nullable type like it is in .NET. It's string. But maybe the fact that you received didn't have one of those. So to be absolutely correct, the developer would really need to do that and then chase down all of the places where TypeScript says there's a problem. So it's like right here, okay, now you're saying that this text in the JSON view model might end up being undefined. And so there's that trade-off. So now things start to get a little bit messy here, but they're true because this is data coming in from the outside world. You can't trust that it's fully set up. TypeScript really works when the data is coming from inside the house. So TypeScript can see the code that generated it, and it can see the code that's using it and say, yes, that's never going to be undefined. But in this case, how can you really tell? So actually, so far, it's that was the only one that it needed to add. So yeah, maybe it doesn't end up polluting it quite so badly. You do end up doing this kind of thing because you have to.
Yep.
But yeah, let the compiler help you to do that. Oh, by the way, we should now be able to get rid of this altogether. Yeah, it just infers the type of message view model. Yeah. In doing this, I fixed a lot of the weirdnesses with the way that I was declaring types. I said, no, let's really nail this down and make sure that I've got all the edge cases. So it's much better at inferring types now. But yeah, that's where Jinaga.JS landed. There's also been some improvements on the Jinaga.net side. So
you brought over the same things to Jinaga.net.
Yes, indeed. So here's is it the post view model? Where did let's start with the model itself. Okay. Yes, so what I am working through right now is that in an earlier version of, actually, yeah, we're seeing the earlier version right now. I must have reverted because this started to run into errors. I'll look back at the other one and see what happened there. Okay, so we initially defined a site to be something that a user created and has a domain. But that means the domain can't change. What if we need to identify the domain and then mutate it? So we should be able to say, there's the fact type. Oh, that's right. I did all this in interactive notebooks. That's why I'm not seeing. Let's see if I can find that notebook real fast. Yeah. So let's go to blog Maui. And maybe it wasn't in this one. Maybe it was in the Jinaga.net notebook. Or in the Jinaga.net project. Okay. Oh yeah, versioning IPYNB. Okay. So I'm on main. Let me switch to the test versioning. There we go. Now we've got a, this is what I was playing around with. Yes. Okay. Come on back to the actual notebook. Oh, where'd you go? Versioning. IPYNB. Okay. All right, so let's just bring in unit test and graph viz. Oh, I was doing that. Okay. All right, so now we're up to 092, and this has got the fixes that I was working on. Okay, so yeah, this is the model that we start with has a title in the post itself, which means that the title can never change, and that's going to be a problem. So so let's say that we have in the past created a site and created a post. Now this is what the model looks like. And now we look for all of the posts in the site. And that's actually a more accurate name for that specification. So just give me all the posts where the site is equal to this particular site. So we're going to look for the posts in michaelperry.net and render them out. Perfect. So now we come along and we want to change the model. We want to say, okay, we're going to have post title as a predecessor or as a successor, so that we can change the title. And then at that point, we no longer want title to be part of the identity, because that's weird to say, okay, I'm creating a post that has this title to start with, but then I can change it later. And instead, we want date time created at. So we update the model, which means now we can no longer do this. We can't say, here's a new post with this title. Instead, we'll say date time UTC now, and we will set the title to be minus equals Jinaga client fact new post title. So the title for this post, post 1, and the value is hello world. And then prior is an empty array. So now let's take a look at that graph, and that's what we want to see. Is here's the site now. With the posts are identified by the time of creation, and we can modify the title. Excellent. So now let's go ahead and take a look at the posts in the site, and we should see here's the old post with this one's the old post with the title as part of the identity, and here's the new post with the date time. So really interesting part of this is that I can't get the title out of here because post doesn't actually have a title. If I were to try to say posts.select and then try to get properties of it, I just have, that's not helping me out very much. Oh, that's because I didn't do that right. There we go. I just have created at. I can't get access to the title. But the old one's still there. It still has the title in it. So how do I accomplish that? And so this is what I foresee as an upcoming feature of Jinaga.net. So this part does not work yet. What I foresee is we apply the fact type to an interface, and so right now we don't have to give it any properties. It's kind of a marker interface, if you will. So this record, we'll call it post title v2, implements that interface. And yeah, I'm not sure why it needs a constructor that takes 0 arguments. Is it just messed up? Yeah, that was a bad error. So that way I can kind of separate the fact type declaration from the record. So the record is a specific set. Wait, it's not post title that I'm interested in doing that with. It's the post I'm interested in doing that. Okay, post v2 implements post. So if I were to do that, then I would also be able to still represent v1 in here.
Mm-hmm.
And these two should be able to live side by side. And then in my specification, I want all the facts of type post, but now post is the interface. So the specification still knows that this is a blog post that it's looking for. But what I get back are going to be implementations of this interface. So if I wanted to put some properties on here like string title, so this is going to be a getter only property, then post v2 doesn't implement that properly. So so here I can say string title, and right now we'll say empty string. And so that properly doesn't implement, cannot implement because it's not public. Oh, yeah, that's implicitly public. This has to be explicitly public. Good error message. Okay. So so now when I take a look here, I should be able to get access to, oh, yeah, you can only have one of these at the end. Ah, interesting. Okay. Yeah, I need to declare that in the interface as well. Yeah, so yeah, this idea would let me declare all the different versions that I might know about, and then I could have a different way of getting the information out of those old versions if I wanted to use them in the new stuff. So site do a getter here. That's happy, that's happy, and now no. Yeah, I can at least do that. But yeah, this is where things start to fall apart. So yeah, not yet implemented, but yeah, that is the idea that I'm going for being able to access those properties that are no longer part of the model, but may be important for backward compatibility. Yeah, so that would be true structural versioning. That type information is not in JavaScript, and nor does it need to be in JavaScript because JavaScript is dynamically typed. Here, it's needed because you can't get to that property without it being declared somewhere.
Mm-hmm. But so here you can just work with the type of the record,
mm-hmm.
and no need to calculate an hash of that structure.
Right.
Okay.
Yep. And internally, it's not actually recording any type information. It's just recording the structure. It's just, these are the fields I've got. These are the predecessors I've got. So, so part of this selection would be to take a look at the fields and the predecessors and pick from these two constructors which one is the closest fit. So that's an algorithm that I want to be able to explain very simply so that there's no ambiguity. You should know. I mean, if you just use the same type as before and then create a new one instead of modifying it, then it should pick the right type. But still, real world strange things happen. I want to be able to see just by looking at the code which one it's going to infer. So haven't figured out what that algorithm is yet. But yep, that's what that's going for. By the way, there's something interesting that is happening here. Let's see if I can get back to the place where yeah, let's go ahead and use the interface iPost. Yeah, just so that we're all okay. We're back to a place where this should now compile. Can't infer. This should be now factor type post. Well, at this point, it doesn't need to implement the interface. Okay, yeah, not sure why we're broken at this point, but the graph, if you recall, had oh, I think that's why. No, this was a .NET type error. We'll just go back. If you recall the graph, it had the old one listed right next to the new one. Yeah, this might require a restart in order to make this happen. Oh, which means that I don't have the old data anymore. But if you recall, it had that one's really interesting. I have to see why that did that. But it had one with the created at, one with the title right next to each other, and that was necessary so that we had consistent identity from one version to the next. So even if you can't deserialize a fact, it has to keep track of the identity of it, which is its fields and its type and its predecessors. So basically a fact graph. So so now with this new version, and the reason I gave it a brand new version number, bumped the version as much as I could, is that the fact now is not just a post record like it says here, but it's a post proxy. And that way the proxy can hold on to that graph, and it can use that. It can give that back to you whenever it needs to serialize it back again. Without that, it would try to serialize from the record type, which now has changed, and so it's going to produce a different set of fields and a different set of predecessors. So it's going to be a different identity. So that was the major lift for Jinaga.net to now dynamically on the fly create a proxy type for your fact type, and then deserialize into that.
That's nice progress.
Yep. Yes, indeed.
And I like the way it is handled in .NET with the type information.
Yes. Yeah. It's still Jinaga. That fundamental idea of you're working with graph shows through, but it's also JavaScript. It's also .NET. And those two things are different, and we should honor those differences while keeping the graph idea the same. Yeah, so that is the update. Yeah, so the improving team is making progress on their model. Now they can actually modify the model without breaking things, because they've got some versioning in there. So, yeah, next steps. I'll get Jinaga.net, the site, stood up and start to document things there.
And for the moment, what do they do if they really make big changes? For example, swapping predecessor, successor. That's something that cannot be done with this type of versioning.
Yeah, well, exactly the thing that they ran into is that from one version to the next, they removed a predecessor. And so, or they added a predecessor. Yeah, the other way around. They added a predecessor. And so the old ones didn't have a predecessor by that role, so it was throwing in an exception. So I said, oh, wait, same idea. Those should carry forward and be null references. So that brings up an interesting thing, is that you're serializing it into something that you might have null checks turned on, but it's bringing in a null. The runtime supports it. That null check is just a compile time thing. So you still have to be careful and just decorate your things with nullable, or say, okay, I know that you say it's nullable, but I'm still going to check those kinds of things. But yeah, so using that, they were able to make a model change. Then when it's a really big model change, like swapping the order of predecessor or successor, then you would also end up changing the specification. And this was kind of a workaround that they discovered quite by accident, is that when they added another condition here, a where exists on the predecessor, which you usually wouldn't have a condition that looks like that, but you can write one in LINQ. Then it adds another clause, and it filters out the things that don't have a predecessor. And then it started working because it could serialize everything that it got back. So I think that organically you would change the specification in such a way that you would only get back the facts that are in that particular shape, that particular order, and then you wouldn't see the old version. So in that case, if you did want to be backward compatible, what you might end up doing is still defining your v1 facts, since you don't yet have this shared interface idea yet. You can still just decorate those v1 facts with the same fact type, the fact type attribute. And then you run that specification, get back those v1 facts, run this specification to get back the v2 facts, because the specification filters based on the shape. And then you can project and merge the projections. So, yeah, definitely puts the work on the developer, but who else knows the right thing to do?
Yeah, because the alternative, the one-way transformation, also puts the work on the developer.
Yeah.
Plus, that will add probably a transformation in one place.
Mm-hmm. Yeah, I'm finding that a Jinaga.net view model starts to acquire a lot of that knowledge. So that's where the specification ends up. That's where it does all of the projections. So yeah, with versioning, you're going to end up having the view model support all the various versions that it knows about, and then merge them together and then present it in a reasonable way back to the user. So at the very least, there's a natural place to encapsulate that knowledge So let's just put it into the view model. Now your view just looks at the view model, and then you can even use view models not in the data binding sense, but now that same pattern, and then whenever you need to do any kind of logic, you can just do that based on the projected view model.
Yeah, because if you keep the old facts, you do the summarizing, the projection in the view model.
Mm-hmm.
But if you would do a one-way transformation on your replicator of your facts, then your view model becomes a new version, and it only so it keeps the view models lighter.
Yeah, that's true. And then you would take all of that version knowledge and you would encapsulate that into a class that you can then put into an Azure function or something. You run that in the background. So, okay, pull the old stuff, push the new stuff, and now this client only looks at the new stuff. So it waits for it to flow through that function before it can see it.
Yeah. So you have your old replicator, you have your new replicator, and between the two, it's an upgrade function. And so the new clients connect to the new replicator, and the old clients stay on the old replicator.
Yep.
Yeah. What I like about it, it's working. It's always working. It's a universal way of upgrading, and it keeps your model. You have a new model which is simple, which doesn't carry over all the legacy facts.
Yeah. That keeps the client nice and tidy.
Yeah. Because if you keep adding different fact types, in the end, your view models, if we have that fact type, we have to do that. It becomes a very complicated logic.
Yep. So give the developer the expressive power to choose how they're going to solve the problem. Document the various patterns. Give examples of how you can solve it this way, how you can solve it that way.
I'm wondering what will be the final solution to that.
Yeah, I think that's going to be a community thing. I think I've taken it almost as far as I can take it. Now that I'm seeing other people using it, they're taking it in a different direction. So okay, the community wants that. If it doesn't violate the math, then it will compile and it will run. If it does violate the math, then give them a good compiler error, give them a good runtime error. Let them know exactly what they did, and then let them make the decision.
All right, we'll see where it gets.
Very good. So yeah, we're gonna have to get back to doing the DWS model in .NET.
Yeah, I'm gonna, because it's a long time I didn't look at it. Gonna make some time for that and start building the screens, doing some testing in .MAUI. It was 2 or 3 weeks ago that I started looking back into .MAUI. But it's a whole new environment.
Yes, it is. Yes.
But okay, we will get there.
Yeah.
All right. Next Thursday, I will be there.
Excellent. I will as well.
Okay.
All right.
See you then, Michael.
See you then. Thanks, Jan.
Okay. Bye-bye.
Bye.